one realizes very quickly we've been seeing this technology for decades. I had access to all those programs. Windows, no real wings or control surfaces, no obvious signs of propulsion, and yet this object is witnessed now by 4 separate individuals in 2 separate aircraft.
Hey guys, welcome back to the first of 2 live interviews on this channel today. Let's not waste any more time. I will just say sorry. If you do have any questions, pop them in capital letters in the live chat. It gives me a better chance of seeing them. Although I do have an awful lot of questions that I've been sent over the last few weeks since I announced that Avi would be back on the show. So I will try my best to get to them. But if not, then I apologize. Please keep the live chat nice and friendly, let's say. But let's jump straight into it, guys. So Avi Loeb is the head of the Galileo Project, founding director of Harvard University's Black Hole Initiative, director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and the former chair of the Astronomy Department at Harvard University. He chairs the advisory board for the Breakthrough Starshot Project and is a former member of the President's Council of Advisors on Science and Technology and a former chair of the Board on Physics and Astronomy of the National Academies. He is the best-selling author of Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, and a co-author of the textbook Life in the Cosmos, both published in 2021. Please welcome back Avi Loeb. Avi, good to see you, my friend.
Great to be with you.
Thank you so much. Let's jump straight into it, Avi. I know we've only got an hour. So I guess the first thing is congratulations. We're into year 2 of the Galileo Project. That must be quite exciting.
Well, actually, I should emphasize that as of this week, we have entered a new phase in the project where we are getting data.
Wow.
And we are starting to analyze it. It's basically a test of the system and also the software. So it's really exciting because until now, we just, first of all, purchased the suite of instruments that we might want to use. And it took some time because of supply chain delays and so forth. And then we had to put them together, those instruments, make sure that they work. That took a while. And eventually, we now have them working in concert, and we will start getting data in the coming week and analyzing it. So it's really a new phase, and we're getting to business, so to speak, whereas before, we were preparing for business. So that's a very different phase because, as I said, all over, throughout the process, we are all about getting new data. We want to look at the sky, figure out what's out there, rather than rely on past reports that most of which are either classified or based on eyewitness testimonies that we cannot validate because we don't have access to those experiences directly. So the scientific method is about getting high quality data with instruments that you fully understand, under control. And that's what we are now starting to do. And that's very exciting. It's sort of like a kid, starting to learn about the environment by touching it. So for me, that's the only way to make progress, because if we wait for the government to declassify data, we can wait forever.
Yeah, absolutely. Now, you had some equipment located on the roof of the Harvard Observatory, but
let me correct you. So that was the initial place where we put it, but by now it's moved out. The roof had to be resurfaced, and also it was not an ideal location. And so we now placed it in a different location.
Are you able to let us know where that new location is?
No, because I don't want hackers to sabotage the data collection.
No, that's understandable. Absolutely. So, you're talking about gathering the new data. Once let's say you do get something interesting and you analyze it and, you get confirmation of something genuinely anomalous, how would you release that information and the results if it were to be something like that unique?
Right. So we have a suite of instruments at different wavelengths. We have infrared, we have optical, radio, audio, and obviously we'll first verify that we see the same object in all of them, and that and then of course the question is it human-made, like a drone, a weather balloon, or an airplane, or a satellite, or is it natural, some either an insect, a bug, or some bird, or something like a lightning or whatever. And if the answer is no, then of course it starts being intriguing. And what we plan to do is, once we have good enough data, basically write a scientific paper and share the data with the entire community, so anyone can look through it. It will, because the sky is not classified and we don't plan to hide anything, and our analysis will be transparent. Other people can analyze the same data because we will make it available. The only intermediate step that we will go through is to verify, that we are not misleading. We don't want to cry wolf. And so we want to make sure that the data is reliable, that we understand what we're seeing, and then let anyone that wants to look at it. So in that sense, it's, I would say, a breath of fresh air into this subject that had a lot of secrecy, a lot of suspicion, and a lot of people talking about their personal experiences, but that's not the way science is done. Maybe, in religion, you can have a revelation, and many people reported about revelations they had with the religious experience. It's also true when people take some substances, they have their own personal experience. And the point is, science is not done this way. Science is not done based on a personal experience. Science is done based on collecting data that can be reproduced, that it can be analyzed by everyone, that everyone can share, just like the reality we all share. When you drive a car on the street, that's a reality that all the other drivers share with you. And so if you do something foolish, you can bump into another car. And, so the point is, there is a reality that we all share. And that's the reality that science is dealing with. You can go to the metaverse and be in a reality that not everyone shares, that you share, and you look good there, and you believe that that's fun. And also you can take some substances and live in a space that nobody else shares with you, but you feel good about it. But that's not science. Science is about the reality that we all share, meaning that if something happens in that reality, everyone can experience it. And the only reason that this subject did not get sort of the universal experience is because the government collected some data that is classified, and the data is classified because it was collected by classified sensors. The government doesn't want adversaries to be aware of the sensors that the US is using, and therefore the data was not released. So we are breaking that mold by collecting data with instruments that are not classified, that we fully understand, and we will make the data open. And that's all about the reality that we all share. So it's not a matter of one person saying, I witnessed that, like a religious experience. It's not a religious experience. It's about the sky. Okay, if something is flying in the sky, everyone can see it.
Yeah. And this data, will it initially be analyzed by AI, and then possibly, if it then needs further analysis, move to kind of humanize? Is that how it will work?
Yeah. So first of all, I should say humans are not scientific detectors, and a lot of people have an issue with that. And they say, well, in the court of law, sometimes eyewitness testimonies, are counted. But that's because, we don't have anything else. And unfortunately, a lot of people are put in jail for the wrong reason. We know that when DNA testing comes along, they are found innocent in some cases. So science cannot rely on what people say. That is not the way by which science operates. It's based on quantitative measurements by instruments. And so that's the fundamental change here, that we are not relying on someone saying, hey, look at that, I saw something. No, we have instruments that are recording the sky, and we understand how the instruments operate, and they don't have a personality. They don't have hallucinations. They don't have ulterior motives. They don't have beliefs or some prejudice about what they might see. The instruments are just recording things, and we will use just that data. And anyone in the world can look at that data and interpret it the same way. There is no way you can, if a clock gives you a time, you can't just say, well, what does this time really mean? No, you understand how the clock works, and then you know what the time is. That's it. And the same about taking an image of the sky. And it's not about a person's impression. It's an instrument. So that's the first facet of the project, that it's based on instruments, not on people. And that's the way science operates. And the second is, what do you do with the data? And once again, we're trying to be as objective as possible so people can apply the same method. And nowadays, we have artificial intelligence algorithms that can be trained. So in other words, if you have software that you can train on things that you know, like, for example, you tell it, this is an airplane from different angles. These are a variety of airplanes that are in the sky. Basically educate it like a kid. You give it lessons about what might be in the sky. So you train it to identify an airplane, and maybe you go through a lot of iterations where it looks at airplanes in the sky and you say, that is an airplane. And so it understands it. So then that's one thing. Then you train it on drones. You train it on birds. You train it on. So in that sense, the artificial intelligence system is, again, something that is not human, but at least you know how you trained it, and you can apply it to any data set. And that will identify things of interest for us that are unusual, because then at some point it would say, look at that, it's behaving in ways that do not resemble airplanes, drones, or birds. It's something unusual. So it will basically alert us. And then, of course, humans can look at this, but at least we identify the anomalies, the things that are outliers, based on an objective measure, which is a system that was trained. And of course, it might make mistakes, but we could understand those mistakes because, it's a computer.
Yeah, no, absolutely. And this is the thing, we've been crying out for science to take this subject seriously. So to hear all that is, for me personally, is really exciting. So that's really good.
So I will tell you what I noticed over the past year, because for me, it was also a learning experience. Sure. What I noticed is, just like in politics, okay, what happens in politics right now is a very big rift between one half of society and the other half, and it happens in many countries. I'm talking about the US. And this is being driven by the extreme. So you find people on one extreme of the political spectrum making, unsubstantiated claims, and that triggers people on the other extreme to make unsubstantiated claims, because they say, look at the other side, we have to pull in the opposite direction. And then what ends up dominating the discussion are people on the extremes making statements that make no sense. Okay? And that's unfortunate. And they basically fuel each other, because by making unsubstantiated claims on one side, you basically allow the other side to make no sense as well, because they say, look at that side, and so each side is pulling to the extreme. Now, in the subject of unidentified aerial phenomena, I noticed the same thing. On the one hand, you have the scientific community that says, there is nothing, forget about it, let's move on, let's focus on things that are mainstream. Okay, but when you have some evidence of things that are intriguing, that doesn't make sense. On the other hand, you have people who have sort of like religious beliefs. They think, I had some experience when I was 7 years old of seeing something bright in my, near my bed when I went to sleep. And as a result, I'm a believer. I'm an experiencer. And, it's sort of like a religious belief. Now, these people that believe, behave as if they regard this matter as a religious matter, in the sense that they would believe anything. So if someone in Ukraine will claim something that looks similar to what, Navy pilots claimed 20 years ago, they would say it must be true. Why it must be true? Because it resembles what the other people say. To me, it looks like anyone can say anything. Like I can say, look now at the sky. There is something really unusual there that looks like the Nimitz. And so why would you believe me if I just said that? I have to substantiate this claim. I have to provide evidence for that. That's the way science is done. That's the middle ground. That's the common sense. So what I see on this subject are people, on the one hand, making unsubstantiated claims that completely discredit the study of UAP. On the other hand, people that have sort of like a religious conviction that any nonsense being said about UAP must be right because it was said 20 years ago without the evidence necessary for that. Okay? And they fuel each other, because when the scientists see those other people that behave like religious believers, They say, look at that. Makes no sense. Why should we engage in that? Let's forget about it. And then when the other people see the scientists, they say, oh, wow, they're hiding. The government is hiding something. The scientists, we must believe in that. So both of these things make no sense. What we need to do is collect data, evidence that would allow us to figure out what it is. Now, when the government comes forward and says there are things we don't understand, I don't hold them, I don't put any blame on that, because the government is not a scientific organization. So I believe them. I think the government is not a scientific entity that can figure out things, and they just see it because they monitor the sky for national security purposes. They have a very practical task to protect the nation, and at the same time to protect military personnel. Okay, so that's the goal of the government. And given that goal, they monitor the sky. Now, they monitor the sky with sensors that are classified. They will never give you that data, and they see things they don't understand. Okay, that's not their job. If it's not a national security threat, it's not really their job. So here comes the role of science to say, let's help the government. This is a subject of interest to the public, subject of interest to the government. Let's not go to the extremes, either discrediting the subject just because there are some believers that say anything unusual, like all the time there are UFOs in the sky, all the time I see them in my bedroom, all these things. If there is no evidence on one side, no evidence on the other side, let's just figure the evidence ourselves. And that's the way science should be done. And I think that's the same, commonsensical way to approach it, which unfortunately was not, pursued in the past. And so that's what the Galileo Project is trying to do.
Yeah, no, that's impressive, definitely, and much appreciated. Now, in a recent paper and article that you wrote entitled Down to Earth, Limits on Unidentified Aerial Phenomena, regarding the recent report by astronomers in the Ukraine, you concluded that the reported speeds and sizes of the phantom objects would have generated fireballs of detectable optical luminosity at their suggested distances. So my question is, and I will caveat this by saying it's hypothetical, but if new physics was involved and the objects were utilizing, let's say, a warp drive, maybe something like the Alcubierre drive, then wouldn't that fit with what was written in the report, hypothetically?
No, because the thing is, in order to block light, these objects were reported as dark. Okay, so that means that they block light. So if light comes from behind them, they block it. That was the quality of the objects that the paper from Ukraine claimed. Okay, now what is light? Light is electromagnetic waves. So to block light, you really need to have electromagnetic interactions. The object has to block light. Okay, so if there is electromagnetic interaction, there is no way for the object to distinguish between electromagnetic interaction with light and electromagnetic interaction with the molecules of air or with electrons in the air. It must respond to the electric and magnetic fields of electrons in the atmosphere of the Earth, okay? And if it responds to those electric and magnetic fields because it responds to the electric and magnetic fields of light, I don't care what physics it operates by. It doesn't matter. If it responds to one set of electric and magnetic fields, it must respond to the other, because in physics, there is no distinction, no fingerprint that says this is an electric and magnetic field of light, and you behave and you respond to it in a different way than you respond to the electric and magnetic field of electrons that are, bouncing off the surface of whatever object it is. So my point was simple, that if you claim that the object is dark on the background of light, then you can't claim that it will not create a fireball by bouncing off the air as it moves through it. That was the argument. And so then you must get a fireball. On the other hand, if you say the object is transparent and it doesn't really do anything to light, I have no issue with that. It will potentially also move through. I mean, for example, imagine an object made of dark matter. Dark matter, by definition, is not interacting with light. We know that it exists in the universe. In fact, it not just exists, it's the main substance that makes the mass budget of matter in the universe. We don't know what it is. It's dark. It doesn't interact with light. We know that galaxies are made mostly, 84% of the mass in the universe is dark matter. And only 16% is the matter that we are made of. Okay, so when you think about that matter, it doesn't interact with light. If it goes through the atmosphere of the Earth, it will not create a shock, no fireball, nothing. I have no issue with that. So as long as it doesn't interact with light, it will not interact with air, nothing. So definitely there could be matter that goes through air without producing any disturbance. Dark matter does it, okay? Because if it didn't do that, we would detect dark matter. There is a stream of dark matter particles through our bodies right now, through the air. We don't have evidence for that. Lots of physicists would like to get the Nobel Prize for finding what the dark matter is. But we know that it exists. It permeates throughout everything, but we just cannot interact with it. Okay, I have no issue with that. We know that such thing exists, okay? We know it from the gravity that it produces in galaxies, in the universe, and so forth. So there is no problem with that. You can imagine even a spacecraft made of dark matter moving through. But the point is, you would not see it as a dark object blocking light. Right. You will see it as a transparent object. So when the Ukrainian astronomers were claiming it's blocking light, it's dark, that's the issue I had. Then I said, if it blocks light, it also blocks molecules of air, creates a fireball. So that's the only issue.
No, I appreciate that. Thank you for clarifying there. And you talked about dark matter there, and I was listening to an interview you did recently on the H3 podcast discussing dark matter, and I had a thought that, dark matter is this elusive material, let's say, that the universe comprises of, and UAP themselves are an elusive enigma as well. Could potentially UAP be utilizing dark matter to traverse the universe, maybe multiple universes? Could there be a connection?
I should say there are two entities in the mass budget of the universe whose nature we don't know, and both of them are, the dominant. One is dark matter, but there is also dark energy. And now, dark energy is the mass density of the vacuum, the mass per unit volume of the vacuum, and we know that the vacuum is basically doesn't change. It's fixed. So as the universe is expanding, matter gets diluted, and about half of its present age, matter became more diluted than the vacuum. So at that point, the vacuum started dominating gravity on the scale of the universe. That's how we know the vacuum has non-zero mass per unit volume. And the vacuum, in terms of, it actually produces anti-gravity, according to Einstein's theory of general relativity. It actually pushes galaxies away from each other at an accelerated rate. So just think about Newton, Isaac Newton, that discovered gravity, originally, because the legend is that he sat under a tree in the orchard that his family had in England, and an apple fell on his head. Now, if instead of the Earth dominating gravity near Newton, the vacuum was dominating gravity, the apple would not fall down on his head. It will actually fly up at a speed that keeps increasing, as if there is an explosion. That's what the vacuum does. It basically creates negative gravity. And so then, okay, we don't know why. We don't know why the vacuum has a finite mass per unit volume. We don't know what dark matter is. And you can imagine that once, a civilization understands the substances that make these components of the universe, which are the dominant ones, ordinary matter that we are made of is the minority. It's only 5% of the global budget right now. And the dark matter makes about 25%, and the rest, 70%, is the dark energy. So, and as the universe will expand, the dark energy will become more and more dominant because matter will get diluted even more. So the point is, if a civilization understands what these constituents are, they could engineer it in principle. They could use those constituents to, build spacecraft that take advantage of them and potentially propel themselves, more efficiently than using ordinary matter. All the rockets that we use so far use ordinary matter for propulsion, chemical propulsion, and all the rockets that we launched, all the spacecrafts, they reached a speed of about 1% of the speed of light, 10 to the minus 4. So it takes us about 50,000 years to reach the nearest star. And it will take us about hundreds of millions of years to traverse the Milky Way galaxy, about 500 million years with chemical rockets. So that's a very long time. If you want to shorten the time, you want to move faster, and perhaps using either dark matter or dark energy, you can do that. Obviously, we cannot engineer these things because we don't know what they're made of.
Yeah, absolutely. Moving on. A few weeks back, you flew to Washington, D.C. to meet with the NASA Study Committee on UAP. So I'd just like to know how the meeting was and if you had any major sort of takeaways from that meeting. And then finally, I suppose your thoughts on the sort of NASA study coming up for the next 9 months.
Right. So, it was an interesting meeting. It's a mixed committee that is made of, the composition made of people from different paths of life. And so I described the Galileo Project. They were very curious and they asked the excellent questions. Now, with respect to the impact of the committee, it's not at all clear because the mandate that was given to the committee, the charter, was to recommend to NASA by June 2023 whether they should allocate funds to research on this subject. Now, as we discussed before, the Galileo Project is already doing that, okay? So what's the best case scenario? Imagine this committee getting really excited, which may not be the case. Maybe they would say it's not worth studying and so forth. It's really a toss-up because it really depends on the personal views of, we don't have the data to tell us, yes, let's do the research because we know for sure that these are extraterrestrials. So, they might decide one way or the other depending on their personal preferences, and some members of the committee express doubts before they participate in the committee. So who knows how they will go. They might want to line up with the mainstream as of now and raise doubt on the study of this subject. My point is that it may not matter because they will reach a decision whether NASA should invest in that and at what level in June 2023. But in the meantime, and then of course it will take some budgeting delay for NASA. Even if they decide to invest, then they will probably solicit proposals. And so it will take another year before funds are allocated for research. So we're talking 2 years from now where research will be funded. And my hope is that in those 2 years, the Galileo Project will already get very good clues about what's in the sky. So, gladly, we were funded by the private sector. So we don't really rely on the decision by this committee, and we can just move ahead and do the research that is necessary. So I'm saying it's great that NASA is doing it. It will be even greater if they decide to allocate a lot of funding for this research. But by the time that they will allocate the funds, hopefully we'll have some good clues about the nature of this unidentified object.
I hope you're right. I really, really do. But at the same time, I believe, the more eyes on the subject, the better. So,
yeah.
Now, where's my question? I've lost it. Here we go. In another one of your recent articles titled "Let It Be an Intelligent Signal," you write about how it might look to an extraterrestrial civilization if a tactical nuclear weapon was utilized by Putin in this case. So would you mind explaining some of the main points from the article?
Yeah. So frankly, I was reminded of a situation where a kid sits at home and the parents are fighting, okay, and the kids, the shouts are very loud, and the kid is worried that the neighbor may hear those shouts and get a bad impression of the family because, it would imply that, things are not going well, and perhaps the family members are not the most intelligent that you can imagine them being if you were to just see them on the street dressed up and very politely speaking with them. So I felt the same thing. If Russian President Vladimir Putin said that he's not bluffing over the past month, that he's not bluffing and might use a nuclear weapon in Ukraine, and just imagine a situation where he will detonate a tactical bomb, nuclear bomb, and that would create a flare a flash of light that could be seen from a distance. So being worried about what our neighbors might think, I just try to calculate how far away from Earth would that be visible to a telescope like, for example, the Webb Space Telescope that we just launched, which is the state of the art in terms of our sensitivity to flashes coming from elsewhere. And so I found that actually with the Webb telescope, you can see Putin's act only out to a distance which is about 5% of the distance to the nearest star. So it's still within the solar system, and 20 times closer than the nearest star where we have a habitable planet. So Proxima Centauri has a planet next to it, which has a surface temperature similar to Earth. And if there are any astronomers there, they would need a telescope that is 20 times bigger than the Webb telescope, sort of like 100 meters in size, the size of a football field, in order to detect Putin's nuclear flash. Meaning that, even our biggest explosions are not so unusual from a distance, because a meteor like the second interstellar meteor that was about 1 meter in size, when it exploded in the Earth's atmosphere, it released roughly the same amount of energy. So all the time, every decade, every few years, there is an explosion of this magnitude from a rock or an object colliding and burning up with the Earth's atmosphere. So that would be one. So just from one flash, you wouldn't be able to tell much. But if President Biden and other leaders decide to respond, and then there is another flash and another flash over a period of a few days, that would indicate that something unusual is going on this planet, because usually you expect those flashes to be separated by years. And so to me, that would be a signal that you're looking at a civilization that is not particularly intelligent, because they are at the risk of annihilating each other. And just because one of those leaders got frustrated with unsubstantiated expectations. That leader expected a reality that is different than the actual reality, and as a result, that leader is willing, when pushed to the corner, to annihilate everyone together with him. So that is not a sign of intelligence, because if you look at natural selection, in nature, often it's said that the fittest survives. And when you think about interstellar space, whoever survives the longest is the most intelligent, presumably, because that's the measure of success in terms of natural selection. So I would much rather be in the company of people that enjoy nature, enjoy good food, enjoy the company of friends, than people who develop technologies that can destroy everyone. Okay, perhaps that's a better approach. Perhaps that's the answer to Fermi's paradox. Where is everybody? Okay, well, either they kill each other over a short time, or the ones that survive for a long time just enjoy the good food and the company of friends on their planet.
Yeah, it's interesting. It was really interesting to read through it as well. I will just say to anybody watching or listening, if you just head to the description below, I've put the link where you can go and read all of Avi's essays. Believe me, they are absolutely fascinating. Now, in that last bit, you mentioned interstellar objects, and you recently announced an expedition to retrieve fragments of an interstellar meteor near Papua New Guinea. So could you give us some background on the object, your hopes for the expedition, and the best possible outcome if it all goes as planned?
Right. So this is the first object from outside the solar system that was spotted actually by US government sensors, presumably satellites and ground-based sensors that are monitoring the sky as a missile warning system. And back in 2014, on January 8th, there was an explosion about 100 miles off the coast of Papua New Guinea that released a few percent of the Hiroshima bomb energy. And it was spotted by these sensors and identified as a meteor, as an object that burned up in the atmosphere that came from outside Earth. But what's unusual about it is that it moved at 45 kilometers per second, when it exploded. And we calculated with my student 5 years later that it actually must have come from outside the solar system. So we published a paper in 2019 about it, saying this is the first interstellar meteor, the first interstellar object. 4 years, almost 4 years before Oumuamua, which didn't collide with the Earth. This object was 0.5 meter in size, 100 times smaller, or 200 times smaller than Oumuamua. So we could see it just because of the fireball. So it the detection was not relying on it reflecting sunlight, as in the case of Oumuamua. And so it took 3 years for the government to officially release a letter from the US Space Command under the Department of Defense, confirming our conclusion that indeed, this object came from outside the solar system at a 99.999% confidence. And at that point, our paper got accepted for publication after the reviewers gave us a hard time for 3 years because they said, we don't believe the US government. So anyway, our paper is accepted, and then we announced this expedition, and within a couple of months, I received full funding at $1.5 million for it. I must say that, there are lots of people that are very excited about this line of research. So, when you work in the mainstream, you have the company of a lot of people. You feel a fuzzy, warm feeling that, you don't take any risk and everyone is. But once you, start to consider something that could be quite exciting, suddenly, you find an audience of wealthy individuals, of people that are excited by the vision. And I must say that the funding, instead of relying on committees, the funding is much easier to get through. And so we got funded, and we now have a team of the very best people in the world that have experience with expeditions. We identified a boat, we are developing the machinery, and we hope to get there within 6 months and scoop the ocean floor for the fragments and basically examine the composition. Because from the government data that came out together with the letter, there was the fireball light curve of this explosion. And by analyzing it, we concluded that the material strength was tougher than iron, that this object was actually tougher than all 272 other objects in the catalog of the government. So it's really rare. And the question is whether it was natural or maybe made of an alloy, like stainless steel, an artificial alloy. So we want to figure out whether it was a technological relic, like a spacecraft, rather than a rock. And if we find any gadget on the ocean floor, I already promised the curator of the Museum of Modern Art in New York City that I'll bring it for display there, because for us it would represent modernity, even though for the senders it's ancient history.
No, it's exciting. I'm looking forward to following along with it as it progresses through. So thank you. I'd like to move on to a few questions that I've been sent from listeners and followers and stuff. So Christian, like to ask, are you potentially looking at any locations for equipment situated in or around war zones or domestic locations with nuclear facilities?
Yeah. So the issue with both of these is that that governments are using things that they regard as classified in those locations. Either nuclear facilities. The concern in terms of national security is that someone will sabotage or have use some terrorism to impact the national safety of the country. And so in war zones it's even worse, because governments are using all kinds of equipment that they prefer nobody to know about. And I'm sure that in Ukraine there is a lot of there are lots of devices that people are not aware of, that are collecting data, that are directing the troops and doing all kinds of things, including espionage and so forth. I'm sure that there is a lot going on that we are not aware of, that reporters do not really things flying in the sky, the reporters are not monitoring them. And so once you go to these areas and you start monitoring the sky and dispersing the data, you will get into trouble, because governments will start haunting you. And the governments do not want you to identify those things because their adversaries will be aware of them. Okay, the governments, during a war, governments use a lot of devices that they prefer nobody else to know about. So I don't want to get into trouble, frankly. And I think the reason that there were lots of reports by military personnel, by people near nuclear sites, is because these parts of the sky were monitored. The government monitors them for national security purposes. So obviously, when you monitor, you see unusual things. But so far, when we looked at the statistics of unidentified objects, it looks like it's perfectly correlated with population density or the frequency of monitoring the sky. So the more people monitoring the sky, the more reports you have. The more cameras are looking around, be it military or civilian, the more reports you have. So it's a very simple correlation. And if you look at all the UAP reports throughout history, you will find that correlation. So what does it tell you? It tells you that maybe it's everywhere, okay? Because the regions that you monitor the most have the most reports, and it's exactly proportional. If you monitor more in one region, you see more UAP, okay? So my point is, let's first start with neutral regions, because then we don't get into trouble with governments. Because so far, the correlation between number of reports and population density is perfect. It's a perfect correlation. I don't see it being nonlinear. In other words, I don't see a situation where there are 10 times more reports if the population density or the number of people monitoring the sky is just 2 times more. So it's not as if the number of reports grows much faster in those particular areas. It's a completely linear. You have 10 times more people, you get 10 times more reports. You have 10 times more military personnel in those regions, in war zones or in any areas that pilots patrol. You have many more eyes on the sky. So you see that the number of reports is just proportional to the number of eyes looking at the sky. That's it. If those areas were preferred, you would see much bigger abundance of UAP reports than the number of people monitoring them. And the statistics doesn't show that. And therefore, I say, let's avoid problematic regions first. And also, the other reason to do that is because there is a lot of noise in this region, in these regions. In war zones, you have a lot of things flying in the sky. So then we have to not only worry about birds or drones or airplanes, we have to worry about all kinds of gadgets that some governments are using for espionage. We have to worry about, satellites that are hovering around just to collect intelligence. So there are lots of things to worry about. Why should I worry about more things? Let's first start with the simple environments.
Yeah. So just carrying on from that, we recently heard a lot about a multitude of sightings by commercial and private pilots known as the racetrack UAP, kind of spanning from the American Midwest across to the West Coast. Would that be more like a neutral location somewhere in there? Yeah. Is that something you've discussed at all?
Yeah, so those would be neutral locations. They are not near any facility that the government deems strategic, And the other place where there were interesting reports are near the shores over the ocean. And so we will definitely attempt to visit such locations. Yes.
That's really interesting. Thank you. Where's my next one? So Echoes in Lo-Fi says, in a recent interview with Kurt Jai-Mungal, Avi said that he would investigate conducting a range of experiments using CE5 to potentially record the appearance of UAP and to see if there is a potential connection with human consciousness. Is that something you intend to look into?
Not in the first round, but potentially later on. So, we have to prioritize the effort. So first we start with the instruments, looking at the sky. Let's see what we get. And then as a second phase, yes, that would be interesting because, the human component is obviously important to many people. So, but we want first to just look at what the instruments are recording.
Yeah, absolutely. I'm going to move on to a few questions that have been appearing in the live chat. I tried to note them all down. If I miss yours, I apologize. So first up, Ender Williams says, will they be releasing the specs for the instruments so that it might be reproduced by others?
Yeah, definitely. And in fact, we have a set of papers that will eventually be published, about 8 of them that will be published in the Journal of Astronomical Instrumentation. They are currently being reviewed, and they provide the details about the instrument. So hopefully in the coming months, by next summer, they should be published.
Fantastic. Witness Citizen, hey Sean, how's it going? Sean asks, is there anything that could maneuver too quickly or erratically to be picked up by his sensors or cameras?
Yeah, so there is a certain frame rate by which any movie, any film that you see shows you a set of still images, and the only question is, what's the separation in time between those still images that gives you the impression of a movie? And so we will have a frame rate of several tens per second. Now, one thing, there was a report about those objects by the Navy pilots, the Nimitz incident, where they saw an object at one point in the sky, then immediately after that at another point, and they said it must be moving very fast. One issue with that is it could be that it's not the same object, that objects come in and out of view, and you see one object at one point and then another one at another point a bit later, and you think it's the same object, but it's not the same. So obviously having a very fast frame rate will allow you to track it if it's the same object. And the other thing that some people suggested, maybe it was a laser beam that was creating a spot at one and then moving to another point and making a spot. And these are the kinds of things that we can figure out if we have a high frame rate.
Yeah, great, thank you. The next question comes from Penny. Does Mr. Loeb think plasma has an integral part to play in UAP presentation, a precursor?
Yeah, so a plasma is a hot gas. Basically, you take, for example, air, and you heat it up to very high temperatures such that the atoms collide with each other and break up into free electrons and ions. So that's what a plasma is. It's just a state of gas where the atoms are broken into their constituents, the charges, the electrons and the ions. And so you get that naturally when, for example, you have an explosion, or when an object is moving very fast through air such that it heats up the air to high temperatures, or when you shine a powerful laser on air and you create a local explosion, then you get plasma. When you explode, detonate an explosive, you get a plasma. You also get it in the sun, where there is nuclear burning in the center, and so everything. Actually, most of the ordinary matter in the universe is broken up to free electrons and ions, and it's in the state of a plasma. But when our body and everything we look around us, the solid matter is not a plasma. It's made of atoms where the charges are held together. So at any event, the plasma is relevant in the sense that if you have an object moving very fast and it interacts with the air, it will create a plasma around it because it will heat up the air. And we see that with meteors. We see the fireball that I mentioned before, that's the energy released by the friction of the object with the air. And we see also around airplanes that move very fast. We see that around rockets that move, around projectiles that move through air. Especially if they move supersonically, they produce a shock wave that heats up the air and breaks up the atoms and molecules into electrons and ions. So definitely relevant. Another context where it's relevant is if it was not really objects that, for example, the Navy pilots were seeing. It was a laser beam focused on air. Just like, sometimes people try to fool cats and they shine a laser spot and move it around very fast. And it's not a real object. The cat thinks that it's a real object. So you can, in principle, fool, pilots by generating a laser beam, shining it, on a spot in the air, creating some plasma ball there. And that would reflect the radio waves. And so the pilot would think, oh, wow, there is an object there, but it's not really an object. It's just a ball of hot air that you create by the laser focus there. And then you can move the laser very quickly to another spot, and you will think, wow, this object really moves fast. So it could be that some of the incidents relate to this phenomena, and someone was just shining laser beams and fooling the pilot. I don't know, but the point is, we want to figure it out, and it's just that the data from the past is not good enough for us to tell what it was.
So if, for example, you mentioned there these lasers potentially fooling people, if you were to see a plasma acting in a what seemed to be a controlled way, how would you be able to differentiate between it being a laser or something genuinely not of this earth?
So if you have a high frame rate, you can tell that, there is a spot at one point and then it goes away, and then another spot is created at another point, but it's not an object moving through the sky from one spot to another. You would be able to tell that it's two different occurrences, two explosions that were created, presumably with a laser. The other thing is that you might be able to see the laser beam as it gets focused. You will see it, and you will not just see the plasma. So that's one way. You want to see that it's a real object. Okay, that's the important element. And a real object, when it interacts with the air, it creates a sound wave, that you could listen to. For example, in the Galileo Project, we have microphones that go well beyond what the human ear can listen to. So it starts at what's called infrasound and goes to ultrasound. Turns out that the human ear is tuned to protect us against threats, So very long wavelength sound waves are not useful for survival because they don't carry much information. And very short wavelength sound waves are also not useful for survival because they cannot propagate a large distance through air. But in the Galileo Project, we are expanding the range and using special microphones to detect sound waves of all types. And from the sound that an object makes, you can tell, like if it's an explosion by a laser beam, it will make a very different sound than an object moving through air from one point to another. So we should be able to figure it out. I have no doubt about it. And now the thing that I think people jump too quickly to conclude is maybe there is some new physics. Well, the point is, physicists work really hard and they have been doing it for decades in laboratory experiments to look for new physics. And, it's very difficult to find new physics. The standard model of particle physics was not really revised in maybe half a century. I mean, the Higgs boson was discovered, but that's old news from the 60s. So in a way, it's really unclear how much new physics there is and room for new physics. I just got an email from someone an hour ago saying, maybe gravitational waves affect the way that an object appears. Well, whoever sent me that email doesn't understand that in order to produce strong gravitational waves that would affect what we see, you really need an object with a mass similar to that of the sun. Okay, a very big object. Such a very big object, the mass of the sun, that disturbs space and time around it to the level that would create gravitational waves that changed our view of the object. An object that has that mass will move the Earth, shake the Earth back and forth just by Newton's law of gravity. Forget about gravitational waves. If you bring another sun close to Earth, it will just pull the Earth and tear it apart, break up the oceans. You can't say, there is an object generating gravitational waves that is really anything except generating gravitational waves. Like, that doesn't work. So people throw out all kinds of explanations that really make no sense from a physics point of view. And even if you think about new physics, you have to make sure that what you're talking about makes sense. Some people talk about wormholes. Like, okay, well, we don't have even a solution that is stable to the equations of physics as we know it that would allow a wormhole to exist. Okay, so you are contemplating something, but then you have to, if you are contemplating it, just try to infer what are the properties of this something. You can't just say wormhole and say, I see a hole in the clouds, that's a wormhole. Like, that's not a wormhole. A wormhole has some properties of space and time, and you need to show that indeed what you're talking about makes sense. So that is not done by people who throw out new physics as if that would solve the problem. If you have new physics in mind, it has to, not only explains one thing, but also predicts something else. And it will apply to everything in the universe. Like, if you have a wormhole here, it should exist in many other places in the universe. We haven't seen such evidence so far. So you can't just say new physics, just because a Ukrainian astronomer got data that doesn't have good distance estimates. You can't just say that, because to argue that there is new physics, you really need exceptional distance estimates. And the elementary way of measuring distance is by triangulation. That's really simple. You just have multiple sites looking at the same object, you triangulate it, you find the distance. The Ukrainian astronomers did not do that. Okay, so I pointed out the distance estimates are not trustworthy. Then people jumped at me and said, why do you say that? In the Nimitz incident, we saw things behave like, but that you know, the Nimitz incident has nothing to do with Ukraine right now, in the sense that this is a completely new event, okay? And if you don't measure distance correctly, you can't justify the distance measurement by something that happened 20 years ago. The something that happened 20 years ago doesn't say anything about what the Ukrainian astronomer did in 2022. That's a completely different set of events. You can't just say there was an event 20 years ago, therefore this event is correct. Like, you have to measure, you have to show by triangulation the distance. And they actually measured the distance to one luminous object, and that distance was exactly the distance you expect for a spy satellite. I just put it in Google. You know, I don't work in anything related to spy satellites. I didn't know what the elevation of spy satellites is. I just put in Google spy satellite. And here it is, exactly the elevation that they were talking about. Now, they put it in their paper as an unidentified object. And I say, why didn't they just put it in Google and see that what they are talking about has the properties of a spy satellite? Like, why would that look strange in a war environment over Ukraine, to have a spy satellite monitoring what happens on the ground? So they saw a spy satellite. That's the only case where they actually had two sites looking at an object that was actually luminous, not dark. And I say, how can you put it in a paper as an unidentified object if that's exactly the kind of elevation and the kind of size of a spy satellite? Like, that to me illustrated that they're not careful.
No, I appreciate you sort of coming on and being able to sort of follow on from that article and give your side of it. So yeah, thank you for that. Just before we finish up, I'm going to go to this question from Jay Allen. Has Avi's team been given any specific areas to focus on via Lou Elizondo, meaning specific spectrums and telemetry to focus on measuring for data acquisition?
Yeah, so of course Lou is part of the team, and the same is Chris Mellon, but they cannot disclose classified information. They signed an NDA when they worked in government, so we are not asking them for anything. So they did not really guide us. They just made general statements similar to the public statements that everyone else heard. And, you know, of course, in principle, they can just tell us, don't do that. Like, if we are saying we will do this, and they say, no, it's a waste of your time. So far, you know, they haven't said it to us. And but otherwise, they didn't give me any specific data or information. And frankly, I don't want them to get into trouble. So I'm not asking. Yeah. You know, my approach is just like a kid. I want to get the data, you know, fresh and without any issues with authorities, because why should we get into trouble if we don't need to?
Yeah, no, I appreciate that. Well, listen, before we say goodbye, Avi, I'm just going to give a quick shout out to Jimmy. Thank you so much for the $5 donation. As I mentioned earlier to everyone watching and listening, please go and check out Avi's essays. The link is below, but also the Galileo website. And you can also donate to the Galileo Project as well if you feel so inclined. Avi, thank you so much for joining me again. It's always an honor and a pleasure to speak with you. So thank you.
Thank you so much. And we will do our best to bring some news within a year so we can chat about substance in a year.
I look forward to it, and we'll have to get you back on to discuss that as and when it happens. To everyone in the live chat, thank you so much for all your questions. I hope you enjoyed this past hour. I certainly did. I will be back live in just under 2 hours with Alejandro Rojas, so come and join me for that one. For now, guys, I will see you later. Thank you. Goodbye.